Algebra word problems number 35b, write, solve equations for mixtures. We're going to solve for x. So this is one variable. We're going to be doing two variables in the next coming up videos. Making a table is the easiest way to find equations needed to solve a mixture problem. So here's our problem. How many pounds of dried fruit mix costing $3 per pound, that's the first bag here, should be mixed with 8 pounds of a nut mixture costing $4.50 per pound to make or give a fruit nut mixture costing $4 per pound. So we need to mix these two together to get this guy, okay? We need to combine the dried fruit with the nut mixture to make a fruit nut mix. But how many pounds of the dried fruit will we need? Well, we know that this is $4.50 a pound and there's 8 pounds here. We know that this is $3 per pound, but we don't know the pounds. So that's going to be our x, isn't it? That's going to be our unknown. And then it's going to make this fruit nut mix that when we add these together, it's going to tell us what that is. See? So x is going to be the pounds of dried fruit that we need. So we're going to make our table. So if you saw the last video, you saw this table. And this is going to help us. And I want you to think of this as row A, B, and C. And in row A, we put our cost per pound for our dried fruit, $3, our nut mix, $4.50, and our fruit nut mixture of $4. See? $3, $4.50, and $4. $3, $4.50, and $4. The second row, B, is the number of pounds. So we don't know what the pounds of dried fruit are. That's X. We do know that there's 8 pounds of the nut mixture. So that's 8. Okay? So the X is the dried fruit and the 8 is the nut. And whatever they are added together is going to give the fruit nut mixture. So we need to add X plus 8. Then this is our value of dollars, cost per pound. Whatever this costs per pound, $3, times how many pounds we have is going to tell us how much we need to pay for it, right? So this is our value of dollars for the whole amounts, and it also gives us our equations. So we multiply coming down on all three of them. All three of them we multiply coming down, okay? So 3 times x is 3x. $4.50 times 8 is 36. See? 450 times 8 came out as $36. And really there's a decimal point here, but I'm just going to use the 36. And our fruit nut mixture is going to be multiplied also. 4 times 4 plus 8. So that's our equation. 3x plus 36 equals 4x plus 8. So here it is. Here's our equation. So the first thing we need to do, step number 1, is to remove the parentheses from this right side by the distributive property and by multiplying by 4. We're going to multiply the 4 to both of these numbers and take the parentheses away. So if you remember my mother bird in a parentheses nest, she feeds the first one and then the second one. Okay, she doesn't skip anybody. Nobody starves here. So we go to 4x, and 4 times x is 4x, and then we go to 4 times 8, which is 32. And now the parentheses are gone. So now we put this in place on the right side, and our new equation is 3x plus 36 equals 4x plus 32. Okay? So there's our equation. 3x plus 36 equals 4x plus 32. I'm going to subtract 32 from both sides of the equal sign to begin to isolate x to one side. So because this is a plus 32, we're going to do minus 32. And we're going to do it to both sides of the equal sign. And on this side, we create a zero pair. Plus 32 minus 32 is 0. So there's a 0 here. There's nothing there. On this side, 36 take away 32 is 4. So now our new equation is 3x plus 4 equals 4x. So now, 3x plus 4 equals 4x. We subtract the 3x from both sides to isolate the x to one side. So we can subtract the 3x from this side. It creates a 0 pair, just like we did up here. Plus 3x take away 3x is 0, nothing. So now we take the 3x away from this side, and it gives us a 1x, right? But we usually don't write the 1 in front of the variable, so it just gives us x. So 4 equals x. That means we need 4 pounds of the dried fruit to make our fruit nut mixture. So now we know. It's not an x anymore, is it? It's a 4. We need 4 pounds of this guy. See? 4 pounds plus 8 pounds means that one would be 12 pounds, wouldn't it? So we'd even be able to know the pounds of that one. All right, we're going to do another one. And I hope these are helping. And if you keep following, you're going to get real good at mixture problems. I'm going to be doing solving for x and y in the coming up videos. So you might want to watch that because it's a little higher level. Okay? I'll see you there. Keep your chin up. Bye.